Welcome to DeepSeek R1, the free AI revolution that outsmarted OpenAI. Today, we're diving into a Sarah versus Alen showdown shaking up the AI world. Imagine a scrappy Chinese lab taking on the giants of language models, like OpenAI, and winning, all while giving their tech away for free. That's DeepSeek, and their new model, DeepSeek R1, is turning heads by matching the power of OpenAI's O1, but without the hefty price tag. How'd they do it? We're breaking down their secret sauce. Think clever twists on reinforcement learning and a model that literally thinks out loud. Stick with us as we unpack the innovations, the benchmarks, and what this could mean for the future of AI. Let's get started.
Okay, so have you heard about this Chinese lab, DeepSeek?
I can't say that I have.
Yeah, so they've really made a splash recently with their new language model, DeepSeek R1.
Hmm.
Yeah, it suddenly popped up like right alongside OpenAI's O1 model. You know, in all those performance benchmarks.
Oh wow, that's pretty impressive, especially considering OpenAI's dominance in the field.
Right? And here's the thing that really caught my eye. You know that O1 model costs like $200 a month to use?
Yeah, that's a pretty penny, yeah.
DeepSeek, though, they went and made their model completely open weight.
Oh wow, so anyone can use it.
Yeah, pretty much anyone with the computing power to run it can use it for free. No subscription fees or anything.
So it's a real David versus Goliath situation then. A newcomer challenging the established giant and making their technology freely available? That's a huge development.
That's a huge development. Totally. So for this deep dive, we were really curious about how they pulled this off, like what's the secret sauce? Well, lucky for us, they actually released a really in-depth paper outlining their métier.
Oh, that's great.
And it turns out a lot of their success comes down to some really clever innovations in how they're training these models, especially in the area of reinforcement learning, or RL.
Ah, RL, yes. That's become a really hot area in LLM development.
Absolutely. So our goal today is to break down the most important parts of that DeepSeek paper for you, so you can really get a sense of what they did differently.
Yeah, I think that would be really valuable to really appreciate the significance of their work. It's helpful to understand, the typical process for training these large language models.
Right. It can get pretty complex.
It can. DeepSeek's paper describes this process as having two main stages. You have pre-training and then post-training.
Okay, so pre-training and post-training. I like that.
It's a good way to think about it. Pre-training, you can kind of imagine it like the model is absorbing this massive amount of text data, learning grammar, vocabulary, all sorts of concepts, almost like a young child learning law.
Okay, so that's like the foundational knowledge, like just memorizing a ton of information. And then post-training comes in.
Exactly. Post-training takes that initial foundation and focuses on teaching the model how to actually use that knowledge. You know how to be a useful and engaging conversational partner. So it's a much more intricate and subtle process.
I see. So it's not just about memorizing facts anymore. It's about how to apply them effectively.
Precisely. And while pre-training requires this huge amount of computational resources to process all that data, post-training involves, a whole range of different techniques. DeepSeek even refers to them as different sauces in their paper.
Causes.
Yeah, it's kind of a fun way to put it, but essentially we're talking about things like supervised learning and, of course, reinforcement learning. And it's really within that post-training phase, particularly in the realm of RL, where...
Okay, so let's really zoom in on that then. The DeepSeek paper mentions this quote from Ilya Sutskever earlier this year. He said, "Pre-training as we know it will end." That sounds pretty dramatic. What's he getting at there?
Yeah, it's a bold statement for sure. And if we think about the bigger picture here, Sutskever's quote suggests a potential shift in the field. See, pre-training is incredibly expensive. It requires these huge data sets and massive compute.
So the focus might shift away from that initial phase.
Exactly. The future of innovation, the key to creating these really helpful and well-behaved AI assistants, would then lie in that post-training stage. Inefficiently and effectively refining those already knowledgeable models for specific T.
Okay, so I'm starting to get the picture here. It's like having a student who's aced all their classes but still needs to learn how to apply that knowledge in real-world situations.
A perfect analogy.
So DeepSeek really zeroed in on improving that application phase, particularly through reinforcement learning. Now, the standard method for doing this seems to be what's called RLHF reinforcement learning with human feedback. Can you walk us?
Absolutely. RLHF has basically become the gold standard for what's called human alignment in most of the mainstream LLMs you see out there. The idea is to use human preferences to guide the model's behavior, and it involves a few key steps. First, the language model generates a bunch of different text outputs, in response to various prompts. Then humans evaluate and rank those outputs based on how well they meet certain criteria. And this is a really important and often very expensive step. DeepSeek's paper mentions that a lot of companies actually outsource this labeling to third-party companies like Scale.ai.
Oh, wow. So they're bringing in a whole army of human labelers.
Exactly. And they even use experts in specific fields like law, medicine, engineering, to make sure the feedback is really high quality.
So we're talking about a significant investment just to get that human feedback.
Right. You are. And that labeled data, those human preferences, are then used to train what's called a reward model.
Okay, a reward model. What's that exactly?
Think of it as a separate neural network that learns to predict how humans would rate a given piece of text. It basically learns what a good response looks like according to human standards.
I see. So it's like a separate AI that's learning how to judge the quality of the language model's output.
You got it. Once this reward model is trained, the process shifts to using reinforcement learning to optimize the language model itself. Generating text is treated as a sequence of decisions. Each word or token is an action.
Okay. So the model is making choices about which words to use to build its response.
Right, and after the LLM generates a complete response, the reward model gives it a score, becomes more likely to produce responses that get. And the goal of the RL algorithm is to update the LLM's internal settings, its weights, so that it becomes more likely to produce responses that get high scores from the reward model.
So the LLM is playing a game where the objective is to please the reward model, to get the best possible score.
A good way to put it. The most common algorithm used for this is Proximal Policy Optimization, or PPO. Without getting too deep into the technical details, PPO basically involves two parts. You have the actor, which is the LLM itself, learning to generate better text. This is its policy, its way of acting. And then there's the critic, which is like another neural network that tries to assess how well the actor is doing. It helps figure out when the LLM's responses are better or worse than expected.
Got it. So it's like a self-evaluation system built into the learning process.
You could say that. PPO also has this neat mechanism called clipping, which makes sure that the changes the LLM makes aren't too sudden or drastic. This helps to keep the learning process stable.
Okay. So it's about guiding the model in the right direction gently, rather than making big leaps that might throw it off course.
Precisely. So that's the standard RLHF approach. Now here's where DeepSeek really shakes things up.
This is where it gets interesting.
Their main innovation lies in a modified version of PPO, which they call Group Relative Policy Optimization, or GRPO. And the biggest change they made is that they got rid of the critic network.
Wait, they just got rid of it? That seems like a pretty major change.
It is, and it has some big implications. DeepSeek points out in their paper that these critic networks are often almost as large as the language model itself.
Wow. So that's a lot of complexity they've removed.
Exactly. So by eliminating the critic, they significantly simplified the algorithm, made it much more efficient and easier to train. And for you, this could mean we might start seeing more efficient, maybe even cheaper ways to train these powerful AI models, which could have a big impact on who gets to participate in this field.
Right? That's a really interesting point. So no more critic. How does GRPO actually work then? How does the model know if it's doing well without that internal evaluation system?
Instead of relying on a separate critic network, GRPO has the policy, LLM itself generate multiple different output responses to the same input. Then those different responses are all directly evaluated by the reward model.
Okay, so it's generating multiple versions of its response.
Right. And the idea here is that if the LLM is confident in its response, it'll tend to generate very similar outputs. But if it's unsure, the outputs will be more varied. The reward model's evaluation of those different responses gives you an estimate of the value of the response, which essentially replaces the function of the critic.
That's clever. It's like the model is looking back at its own work, trying out different approaches, and then figuring out which one worked best based on the feedback it got.
That's a great way to think about it. So this simplification with GRPO allowed them to implement another really important improvement, which is the introduction of these thinking tokens.
I've heard a little bit about these. This is where they basically give the model permission to think out loud, right?
In a way, yes, they insert special markers in the text for thinking and you for answer, and anything the model generates between those thinking markers is not directly evaluated by the reward model. Only the content within the answer tokens actually counts towards its score.
Okay, so they're giving the model some free space to explore different ideas before it has to give the final answer.
Exactly, and they found that giving the LLM this free space to think actually significantly improved its reasoning abilities. It's as if the model uses this internal space to try out different approaches or lines of reasoning before it formulates its final answer.
So it's like giving the model a scratch pad to work things out before it has to write the final answer on the test.
Precisely, and the results really back this up. They found that the average length of the responses within that thinking mode steadily increased throughout the RL training process, and as that thinking increased, the model's performance also got better. They saw a lower loss, which means the model was getting better at giving the desired responses.
That's fascinating. It really seems to support this idea that giving the model that extra space to think actually helps it perform better.
Absolutely. And here's another interesting point they made. With this method, they achieved comparable performance without needing supervised fine-tuning or SFT beforehand, which is another standard step in the process.
Right. I remember you mentioned that earlier. That's where they train the model on a bunch of human-written examples to give it a certain style or format.
Exactly, and gathering that high-quality data for SFT can be pretty expensive. It often requires human experts to write those examples. The way DeepSeek manages to effectively sidestep this stage speaks volumes about the remarkable efficiency of their strategy.
So they streamlined the RL process with GRPO and added these thinking tokens. They managed to hit that top-tier performance without the cost of the critic network and all that SFT data. That's really impressive. But their paper did mention some challenges they ran into, right? Something with the model's usability at first.
Yeah, that's right. They found that completely skipping SFT did have some downsides when it came to how user-friendly the model was. What do you mean? Well, it was great at reasoning and figuring things out, but it wasn't always so great at presenting its answers in a way that humans would find easy to understand. You know, things like formatting, using bold text bullet points emojis, those were often missing. It was like it had all this knowledge but hadn't quite learned how to communicate it effectively with humans.
So it was a bit rough around the edges.
Yeah, you could say that.
So how'd they fix that? Make it more presentable?
They took a very practical approach. They incorporated a little bit of SFT using what they call cold start data. This data was basically human-corrected outputs from their initial model, DeepSeek R1.
So they used the model's own output and then had humans clean it up a bit.
Exactly. By fine-tuning on this relatively small dataset of human-refined responses, they were able to teach the model better formatting and style without sacrificing the core reasoning abilities they had developed through those RL innovations.
So they gave it a finishing polish to make it really shine in real-world use.
Good analogy.
And there was also that interesting point about multilingual reasoning, wasn't there? Something about the model thinking in one language and answering in another.
Ah, yes. That was a fascinating observation. During that initial RL training, they noticed that the model would sometimes do its internal thinking in one language and then give its final answer in a different language.
Okay, so it was like switching back and forth between languages.
Yeah, which is not ideal from a user's perspective.
Definitely not. It wouldn't make for a very smooth conversation.
Right? So they had to find a way to fix that.
What did they do?
Their solution was pretty simple and straightforward, actually. They just added a penalty to the reward function whenever the model switched languages between that thinking phase and its final answer.
Oh, so they basically discouraged that behavior by making it less rewarding for the model.
Exactly, and that pretty much solved the problem.
That's really neat. They identified a specific issue and came up with a very targeted solution. So after all these clever adjustments, GRPO thinking tokens, a little bit of targeted SFT, they ended up with a model that really excels in those performance benchmarks, right? The DeepSeek paper has a whole table showing their results.
It does, and the benchmarks really show how successful their approach was. DeepSeek R1 scores incredibly well, often matching or even beating much more resource-intensive models.
So they're really punching above their weight.
They are, and the main takeaway here is that they've proven it's possible to achieve state-of-the-art performance by really focusing on making the post-training phase as intelligent and efficient as possible. It led to a model that's powerful and crucially much cheaper to train and use, especially in that open-weight form.
Okay, so just to recap for everyone listening, DeepSeek, this relatively unknown lab, has developed a language model that can stand toe-to-toe with the best in the world. And they did it by making some really smart changes to how they train the model after it's already learned the basics of language. This new GRPO method for reinforcement learning and this idea of giving the model dedicated space to think, those seem to be the key ingredients in their success.
I'd agree with that assessment. Those are the core innovations that allowed them to achieve such impressive results.
And the fact that they're offering this model for free, unlike some of the other leading models that come with a hefty price tag, that's potentially game-changing.
Absolutely. It really raises the question of what this means for the future of LLM development.
Right. If sophisticated models can be trained more efficiently and made widely accessible, could this democratize access to powerful AI? Could we see smaller research groups and startups playing a much bigger role in the field?
It's a really exciting possibility. DeepSeek's work might signal a shift in focus from simply scaling up model size to developing more intelligent and efficient training methodologies.
And that leads to even more intriguing questions, doesn't it? If we can teach a model to essentially think out loud in a hidden space to improve its problem solving, what other unexpected, maybe even groundbreaking abilities might emerge as these language models continue to evolve?
It's a question that's worth pondering. We might be just scratching the surface of what these models are capable of.
It really makes you wonder what the future holds.
Indeed, the possibilities seem endless.